Friends, so our challenge was to create the doubly linked list, right? And we have created the first part. And now in the second part, we will be adding more methods apart from add first. So our test cases were passing and we were able to print it. So what we will do now is first we will add last method and then we'll go ahead and we'll start testing this entire thing as well. So let's do add last now. Add last, what does it mean is instead of adding this and replacing your first, you would be doing it at last so that you can preserve the sequence of your linked list. So we have add from last or add last, you will get the data from the user, whatever he wants to get added. As simple as you will have a node L which will keep the reference of last element. So imagine if there is nothing in the list, the last would be null. Now you need to create the node. So we would just go here. Actually, this should be E because we are following generics. So your last node, and then here you would say last, and forward would be null because this guy always, there is nothing in front, so the forward would be null for the last node. So I've created the last node, and then the current last node is it's pointing it as the previous for the new node. Now you need to check if your current last node is null, which means the entire list is empty and there is no data as of now. So what you would do is you would make the reference of first as new node so that it would be common for both. Now suppose that your last element, whatever is pointed, is not null. So what do you need to make sure that your whatever is your current last, its forward should be the new node. So what you would do is your last dot next should be the new node. And then you would replace your current last, whatever the pointer, the last is being used, with the new node, and you will increment the counter by 1. So yep, so this is pretty much it. I'm thinking, yeah, we are all set. So let's try to test it. So since we are trying to add it from last, let's also print it the same way. So printing last, we can pretty much use this. We just need to update the reference just to save some time. So you would say backwards. Now, so the first node you would say as last, and until last dot previous is not null, so you would start from here. So then it would take here, and then it's null. So it would stop and it would print entire thing. Now you don't have to add data to check this method. So let's do that first. And then we would say add some data because test-driven development says one step at a time. So we are all good. Second first 0 and 0 first second. Everything is going fine. Now things might go crazy once we add our last element if our references are not added properly. So we would say add last, and then we would say it as second last and then last, just for fun, right? So we would say second last and then we would say last, and then we would print it both backwards and forwards. to make sure our links works both ways correctly. Second was 0, second last, second last, 0 first, second. Cool. So far so good. Now let's start removing the element, and here we can assert that we have 5 elements. So let's do the remove from first. So we need the data back, and we say remove first. You don't need to pass any data because you're going to return it anyways. Now here is a tricky part. If your first is null, which means there is no data, you're at the end of list, so you can return any exception, or we would return null because there is no data as of now. But in case if there is some data, so what you would do is you would say this is your first. Technically this is supposed to be removed, and what we need to do is this will be removed and this will be here. So we need to clear the data for this so that it can get garbage collected. So the reference from here to back and from here to front, both we need to cut down, the very first thing, right? And second thing is we will directly point this to this. So let's do this. First, the removing node. So we can say is node to be removed. So r.data is equal to null, and then r. Previous would have been already null. It's only the next which we need to take care of. So we would say this dot next is equal, but it doesn't harm if you again, let's say previous assign null. Let's do that. So this is done. Now your first new would be your data, which is after this guy, after R. So what we did actually is we should do this thing on first. It's actually the same thing, but let's run. So your current first has to come whatever the first dot next. So and there are two ways of doing this. You can take the reference. You can say first if first dot next is equal to first is equal to first dot next, and the new data first dot next, and its previous should be assigned to null. So this is what you did here. You have updated the reference for the first. So now what we did here is we made first as first dot next. This is our current first, and then its previous would be null. So because this is a new first, so its previous is null. But then whatever the data we have for the removal, we need it to be cleaned up for garbage collection. So we did clean it up. So I think this should suffice. But before removing this data, we might keep the data so that we can return it from the method. So what we can do here is actually we can reference would be deleted. That should be fine. you don't have to do this, so we can do something like this. So this would suffice, right? Now when you're removing your first, remove from first, and first and last are same, so you need to make sure that your last is also remove, remove. So your last also needs to be updated. So usually what do I do here is if yeah, there are several other ways, but if your first, if it's not null and your last both are pointing to the same guy, then I would assign the last as null value, because technically this is our last data here. And when everything happens, we could do count minus minus. So let's check what we are doing. We are ensuring that first data is not null, because before removing from the front, first, we need to make sure there is data. Let's say if there is data and that's the last item, then we have to reference the null to last. If it's different, then like more than 2, then this won't even execute, so not a problem. Then we took the reference of the data to be removed, and then first we assign the next item after first to this data. So we change our first. This sets everything fine. Now for the previous, for the new first dot previous, it might have some data, like this will become the new first. So whatever the data object reference was there, we assigned it to null. And then we since we wanted this to be garbage collected, so reference from this to somewhere else also we have removed. So let's try this here, if everything works fine. I wish so. So what we are going to do is we would remove, and when we remove, ll dot remove first, this is supposed to give us the data, print forwards second first 0, right? So second data is supposed to be back from here. So we are all set with that. And then the count is supposed to be 4. And then let's see if both these methods reflect it properly. We can just move it so that we don't have a lot of white space. What is failing now? So I was anticipating something would fail, but I think the logic is correct. It's just our test. And there you go. So first 0, second last, and last second last. Cool. So we have implemented this as well. This is a difficult part, believe me, and we did it nicely. So the last stuff is to remove from last, and then we are done for linked list. So this would be same. It's just that it's a matter of some references. So what we need to do is, if your linked list last is already null, you need to return the null. If you have only one item and your last and first are pointing to the same thing, and you want to remove the last, which means your first should also be removed and point to the null. Now you would have node E which you want to remove, you would point it to last, and then you need to make your last as the last dot previous. So here the thing has been changed, and you would say last dot next is equal to null. So you remove this, and then you point this to the whatever your last dot previous means, pointing it to here, and then let me show you with some colors. You're pointing this directly to this guy, and then you're pointing, actually this dot next is null, so it doesn't matter. Now you need to break these two links, this guy and then this guy. So you already broken this to this, and there is nothing from here to here. So you need to break this link now. So let's do that. So what do we do now? What do we do now is to make this eligible for garbage collection, we would nullify this. And then we would return the data, whatever the removable node is having, like this. And let's try to print it after removing. There could be some, I hope not, but there could be some issue. So we would say this would remove last, and your data is supposed to be removed once. Okay. So it's good that when you write test, you catch the bugs. So TDD is like really helpful. Now, what are you doing? Okay, let's find what's the problem and then fix it. Hey, cool. We implemented it without any issue. So we have got the second last and zero and first. So let's try to remove couple of more elements and see if we are able to get some corner cases or some issues. So we would call, we have 3 data, right? So let's call it 2 times, and we don't even bother about asserting this because now we know the sequence. So this should be 2, and same thing we would do. This should be 1. And now if our things are printed, that means we are all set. Oh man, we are doing great and awesome. I would say let's remove the last element as well and see if our program is going to handle it or start crying. Okay, we anticipated it. So 71 last dot next. So what we are trying to do here is so from where this problem came, we are trying to remove the last, and if last is equal to null, then we are returning it. So this place, clearly it's not null, but once it comes here, what we find is 71 line, which means here. So if we say we can check this actually here, but yeah, sure. So if your new last, whatever your new last is not null, then you would do this. Otherwise, it doesn't make sense. So this kind of patch you might also need for the first when you're trying to set the first. So if your new first is not null, then the previous. So what typically we are doing here is we have this first, and when we are removing this, so this dot previous is supposed to remove first, right? So we are removing this, but there could be a chance that this guy is null. So if this guy is null, you can't set a previous on that. So in case if this new first is null, then this will give error. So now this should work fine. Fingers are crossed. No, so what's the issue here? 157. Did we mess up with the, okay, so number, which make perfect sense because the count is supposed to be removed. Okay, let's debug this. This is 157. So we had 3 items here. Let's print that backwards and forward at this point in time. 1, 2, 3, 4. So print forward somehow is printing 3 element and print backward is not. So there could be some issue in the print forward or in print backwards. At the last, print forward is still printing these things. So there could be issue with the print, or there could be the issue with the okay guys, so this is a challenge for you. I'll cover it in part 3. I'll show you what was going wrong, and it's like really challenging. So thanks for watching and stay tuned.